Hi everyone. We are going to discuss about pressure sensor. So normally pressure is defined as an expression of the force required to stop a fluid from expanding, and usually it is termed as force per unit area. Actually, this acts as a transducer, that a passive transducer, because it needs some kind of external energy to activate, and it also generates a signal as a function of the pressure imposed. A pressure sensor measures pressure typically of gases or liquids. It also used for controlling, monitoring, and measurement of variables such as fluids, gas flow, speed, water level, and altitude. And before going to the actual pressure sensor explanation, we should aware of the scales used to measure the pressure. So first one is we have atmospheric pressure, gauge pressure, absolute pressure, differential pressure, and vacuum pressure. That will be denoted by using this chart. And if you look at absolute pressure, this is the definite reference point is absolute zero pressure. This is the pressure of empty space in the universe, and this will be calculated as the sum of cage pressure as well as atmosphere pressure. And cage pressure measured related to the ambient atmospheric pressure. It also called overpressure, and this is a positive pressure above the atmosphere and a negative for pressure below it. And this will be calculated by using absolute pressure minus atmospheric pressure. And next we have vacuum pressure. It is the pressure below the atmospheric pressure and is measured by vacuum cages. And this is calculated by using atmospheric pressure minus absolute pressure. And along with this, we have static pressure. That is the pressure of a fluid or gas that is stationary or not in motion. Then we have a dynamic pressure. This is the pressure exerted by a fluid or gas when it impacts on a surface or an object due to its motion or flow. So the difference between these two pressures, static and dynamic. So static is not in motion, and dynamic pressure is when it is motion or in the flow. And impact pressure, that is called the total pressure. It is a sum of static and dynamic pressure on the surface or an object. And this many of us have seen this kind of cages in the flow path or in the tubes, and this is to monitor fluid pressure in industrial process that involves the monitoring of the elastic deformation of diaphragms, bellows, and tubes. And diaphragms, this is one kind of pressure sensor, a thin layer or film of a material supported on a rigid frame. Actually, the movement, so this is the elastic diaphragm, this is the elastic membrane. When the pressure, external pressure is applied on the outer surface, and here in the bottom we have reference pressure. So when the pressure applied, it will be like this, and we have the opposite, we have the reference pressure. The difference, this will deform like this. The diagram will deform like this. So this changes or this deflection will be measured by using this LVDT. So LVDT is actually a displacement sensor. So this displacement sensor measures the deflection of diaphragm due to the application of force. And the pressure can be applied on one side of the film or cage sensing, with the other inlet port being the left open to the atmosphere. So this pressure is applied on both the sides on the film for differential sensing. And this will be measured by using the LVDT, linear variable differential transformer. When the pressure is applied to the diaphragm, the film distorts or becomes slightly spherical and can be sensed by using strain gauge, piezoelectric, or changes in the capacitance techniques. And materials for the diaphragm is for low pressure, we are using rubber or plastic. For medium pressure, we are using silicon. And for high pressure, we are using stainless steel. So these are the materials used for diaphragm. And since the elastic limit has to be maintained, because if the elastic limit is lost, the diaphragm that lost its actual performance. So we have to maintain the check limit. So the reflection of the diagram must be kept in the restricted manner. So this can be done by cascading many diagrams, because if we have only one diagram, then the elastic limit, the life of the will be less. So for that case, we are cascading many diagram capsules. A main capsule is designed by joining two diagrams at the periphery. A pressure inlet valve is a pressure inlet valve is provided at the central position. When the pressure enters the capsule, the deflection will be sum of the deflection of all the individual capsules. If you have n number of capsules, so the pressure will be capsule number 1 plus 2 plus 3. So we can measure the pressure based on the number of diagrams. And types of diagrams, we have the two types: flat diagram and corrugated diagram. So corrugated diagrams increased effective area and greater sensitivity than the flat diagram. So based on the application, based on the effectiveness, based on the accuracy required, we can use any one of these diagrams. And the main advantage of these diagrams, pressure sensor, is much faster frequency response than U-tubes, and good for low pressure. So especially for low pressure, we are using this diagrams pressure sensor, and higher overpressure safety, and used to measure gauge atmospheric and differential pressure. The main disadvantage or drawback of this diagram sensor is more expensive than other pressure sensor. That is the major disadvantage. And next, second pressure sensor we have is bellows. It is a closed vessel with the slides that can be expand or contract. And here we have bellows, and this the outer case, and inside we have bellows. So this is the bellows, spherical shape, and inside that we have springs, and this spring will be connected to the connecting. This connecting will be connected to the sector. That sector we have a pinion and a hairspring, and that will be attached with the scale. So whenever the pressure is applied, whenever the pressure applied on the inlet port, so this will get contracted. So automatically the sector will move like this in this direction. It will be like this. So based on the movement, will the needle will move on the scale. So that will be the direct measure of the pressure applied. So here the pressure is applied. So this will be measured on the scale directly. So that the explanation given, the pressure is applied to the face of the bellows, and it is deform, and its deformation and its position depend on the pressure. And these are the different types of bellows. So compressed type, expanded type, a spring opposed bellows. And the major elements of bellows is made of brass, phosphor bronze, stainless steel, beryllium copper, and other metals suitable for intended service of the cages. The motion of the element, that is bellows, is transmitted by suitable linkages and gears to the dial pointer. So most bellow cages are spring loaded. A spring opposes the bellows and thus prevents full expansion of the bellows. Thus, by limiting the expansion of the bellows, protects and prolongs the bellows life. Because of the elasticity in both the bellows and the spring in a spring-loaded bellows element, the relationship between the applied pressure and bellows movement is linear. That relationship we have to maintain, because if it is not linear, then the life of the bellows will be, it moves towards the plastic stage. And when pressure is applied to the bellows, it elongates by stretching the convolutions rather than the end diagrams. The bellows is the most sensitive mechanical devices for low pressure measurements, that is approximately zero point 0.5 to 210 kilopascal. It is measured absolute pressure, cage pressure, and differential pressure measurements. And the major applications of these bellow cages are mobile phones capturing biometric data, because every places where offices, colleges, so all the places we are using the biometric data. So for that purpose, we are using this bellows, and pressure measurement, force measurement, home automation, security. automobile security, advanced medical devices, communication research, and finally robotics. So far we have discussed two pressure sensor. One is diaphragm and another one is bellows. Thank you. Thanks a lot for watching this video.